Hey, welcome to Sine Law example number 1. We have triangle ABC here, and the first thing you gotta realize is that this triangle is not 90 degrees. And because this is not 90 degrees, you can't use the primary trig ratio SOHCAHTOA in order to solve this question. You gotta use sine law. It's a little bit more effective than those ones. So you're gonna start out by writing out the two versions of sine law here. So there's the one with the angles on top. So sine A over small a, sine of angle B over side B equals to sine of angle C over side C. Now, take into account that I'm actually saying side C because this is the side and this is angle. Okay, I'm trying to annotate or reinforce that these are not just variables, they're actually measurements, certain measurements I'm looking for, right? Angles and lengths. Okay, so that's version 1. The second version is the one with sides on top. So side A over sine of angle A, side B over sine of angle B, and side C over sine of angle C. Okay. I don't know if you remember, but it's easier to solve for an unknown when the unknown is on the numerator. I'm going to repeat that one more time. It's easier to solve for an unknown when the unknown is on the numerator. And so, in this case, what's on the numerator? The angles. So if the unknown, or what they're looking for, is an angle, I would use this to solve for angles because the angles are on top. I don't know if you remember from the previous videos. It's a little bit more work when the unknown is on the denominator. You have to multiply it out. And over in this case, what do we see? What's on the numerator? So in this case, I would use this version of the sine law in order to solve for sides. So solving for sides. This is solving for angle. Okay, and in this case, they're asking us, oh, there's no question, but the question is to solve for the length of x here, or little a. So I'm going to be using this one, at least first, to answer their question, which is to solve for x. Okay, so first thing I'm going to do is, I've chosen this one, and now I'm going to write down the unknowns. So in the case of little a, it's going to be x. Big A is 93 degrees. And little b is 17. And sine of little b is 55. And little c is unknown. Little c is on this side. So, sorry, I shouldn't be saying little c. It is length side c. So side c does not exist. And angle c, we don't just know yet. But we can actually do some work if we wanted to figure it out. We can use our calculator because we know that angles add up to 180. So angle C right here is going to be equal to 180 minus 93 minus 55. And 180 minus 93 minus 55 is going to be 32. So I know that this is 32 degrees. So we can actually put that in there. And now, I don't think you've quite had the experience with an equation that has three expressions here with two equal signs. But what you can do here at this point is you have to choose two of them, because two expressions here, in order to make one equation rather than the 2 or 3 equations that we see here. So we gotta choose. So what am I gonna choose? I'm gonna choose the one they want. They want to solve for x. I'm definitely choosing this one. And so I'm also going to choose this one, okay, because this has no unknowns. And remember, when you choose these two together, I can actually solve for x. If I chose this one and this one, I'm going to have two unknowns, x and c, and I can't solve for x because I don't know what c is. So after you plug it in, all the numbers, you have to choose two of the expressions out of the three that's here in order to make an equation. So I'm going to go down here now, say therefore I'm going to write out, I'm choosing these two, sine of 93 equals to 17 over sine of 55, and I can ignore that one. And now we solve for x. And so to isolate for x, we have to get rid of dividing by sine 93. So the opposite of dividing by sine 93 is multiplying by sine 93. So 17 times sine 93 over sine of 55. And now I can plug this all in my calculator all at once, and I don't have to clear the button. In that case, I'm able to keep every single decimal place and ensure the most accurate answer I can ever have without rounding in between. So sine 17 times sine 93 equals, and it gives me this huge number here, and I'm going to keep that and press divide. So divide, and I don't know if you can see, I'm going to divide by sine 55, and it's 20.7. Dot, dot, dot. There's a whole bunch of decimals there. And depending on which context I'm working in this case there is no context. So now we go back to the fact that we see how many decimal places they have. So no decimal places, no decimal places, no decimal places, no decimal places. We're going to have no decimal places. So we're going to round to approximately the same number of decimal places they have, which is going to be 21. So you have to round up. That's a 7. So the answer to this question is that x is 21 centimeters. So how do I do this question? I'm given a question, a triangle that is not 90 degrees. I'm going to use sine law. I write out the sine law, the appropriate sine law that I need to use. And the one in this case, they're asking for sides. We choose the one with the sides on top. Plug in the numbers. Once we plug in the numbers, we choose 2 of the 3 expressions here to make an equation. And then you solve for x. And then you have your answer. Okay? Let's go to the next video and try something a little bit harder, because I think you guys have leveled up.